Alright, we'll dive into object-oriented programming, or OOP for short, one of the most important programming paradigms that makes coding more efficient and organized. At its core, OOP allows us to create real-world things as objects in code. Think about your phone, a laptop, or even a person. Each of these can be represented as objects in programming. Objects have characteristics, core properties, like a phone's brand, storage, or battery life. They can perform actions which we call methods, like making a call or taking a photo. To work with objects, we use classes. A class is like a template or recipe. Imagine you want to create multiple phones. Instead of defining each from scratch, you can define a phone class once and then create as many phone objects as you need. So by the end of this video, you will learn how to define classes and create objects in Kotlin, what properties and methods are and how to use them, how to work with constructors to initialize objects, what visibility modifiers like public, private, protected, and internal mean, and how they control access to your classes and objects. So let's get started. Imagine you are buying a new phone. Every phone has a feature like model, storage, capacity, and battery life. A phone can do things like making a call or taking photo. In programming, we represent these features as properties and the things a phone can do as methods. But how do you make all of this in code? Let's jump into classes and objects. Let's say you want to model a phone in Kotlin. We'll start by creating a class that represents the phone's template or recipe. The template defines the phone's properties like the brand, the storage, the battery life, and its method like making a call or taking a photo. Here's how we create or define a class in Kotlin. So you start by the class keyword and then the name of the class, which is phone in our case. Then you open and close curly bracket. Inside of it, you specify the properties. So the properties are just normal variables. So create this variable, brand, storage, and battery life. You can also define what the phone can do, which are methods. So methods are functions in program. So you create a function. So we have two functions. The first function for making a call and the second one for taking a photograph. So anytime this function is called, it will bring something like calling a number from my brand phone. So we'll pass this, we'll set these properties when we create a class. In this phone class, the properties, brand, storage, and battery life define what the phone has. The method make call and take photo define what the phone can do. But defining a class is just the first step. To actually use it, we need to create an object. So you come to the main function and let's see how to object from this phone class. So an object in programming is an instance of a class. Think of it like actually buying the phone. You're no longer talking about the rest. You now have a real phone in your hand. So you create an object or instance of the phone by declaring a variable, for example, for my phone. So this is now an instance or an object of this phone class. This is actual phone instance. So we can also assign new value to the properties defined in the class. For example, the brand, we can set it to Samsung. And then my phone, I can set the storage capacity to, let's say, 128 gig. And then finally, the battery life to like 4,000. So we are accessing the properties defined in this class. So this is where we are creating actual object from the class template that we define. So when you are creating the object, you will be more specific. You want your phone to be Samsung or iPhone. The specs, you specify the specs. So this is what we are molding out of the template that we created. Then we can also call the functions that we define inside of it. So we've also called this method. So if we run it right now, print statement in these functions will be called. Let's run it and see that. So you can see the output now through this instance, this phone instance, we are able to pass the phone number so that we make a call and then we call the take photo method to take picture. This is the output. Here, my phone is an object created from the phone class. We set its properties, the brand, the storage, the battery life, and we can use its method, make a call, and take photo. Let's talk about constructor. When we create an object, we often want to initialize its properties right away instead of manually setting each property like we did over here. We can use constructor. Kotlin gives us a feature called the primary constructor, which allows us to pass values directly directly when we create an object. Let's rewrite the phone class to use primary constructor. So to use a primary constructor, you put a bracket between the name of the class and then the curly bracket, and then you declare your properties over there. Run storage. Now we can remove the primary constructor. You no longer need the properties inside of the class, but you pass them like an argument the way you pass it in a function. So you do, and you see our error is gone. So now if you want to create an instance of this class, you have to pass these values directly into the function. So to do that, you can have a new phone, say my phone, which is equal to phone. So now we have to pass all that. The first one is the brand, which is Apple, and then the second one is the storage, which is 64 gig, and then the final one, which is the battery life. We will say 4,000. So you see, we no longer have to do this. We can remove this over here because here we were setting it manually. But once you use the primary constructor, as soon as you create the instance of the object, you can pass the value into it directly. So I have a question for you. Let's say I have a class called phone with properties like brand, model, and color. If I create 3 different phone objects with the same properties but different value, how many unique phone objects can I create? Is it A, 1, B, 3, C, infinite? Let me know what you think in the comments. So let's talk about secondary constructor. Kotlin also supports secondary constructors, which provide an alternative way to initialize objects. If you want to provide a simpler option like a phone that defaults to 64 gig storage capacity, you can use a secondary constructor. Let me comment this and show you how to create a secondary constructor. So if you want to provide a simpler option like a phone that defaults to 64 gig storage capacity, you can use a secondary constructor. So for the secondary constructor, you can have, say, your primary constructor, and then these are your properties inside of it. For the secondary constructor, just like function, you use the constructor keyword and then declare your parameters inside this constructor function. Then you take this as argument and pass it to the properties inside the class, and to refer to these properties inside the class, we use the this keyword. This keyword means that a property of this phone class, we are referring to the phone class. Anytime you see this keyword used, it means it refers to the class itself. So it means that this property is of the class. This one relates to this, but this red one comes from the argument that will be passed through this constructor. So let's look at visibility modifier, a way to control access to your phone. Just like you wouldn't want everyone accessing your phone's data, sometimes you want to control what part of your class are accessible from outside. In Kotlin, we use visibility modifiers to do this. We have 4 types of visibility modifier. The first one is public, which is the default. Everyone can access this property. We have private, which only the class itself can access it. And we have protected. For this one, only the class and its subclasses can access it. And the last one, which is internal, accessible only within the same project or module. So let me show you an example. For example, let's say we don't want anyone outside the phone class to change the battery life. So here we put private keyword before the variable battery life. This way it protects the variable battery life from being accessed outside the class. So let's say we declare the phone and then give it the initial value of Apple 64 gig and then a battery life of 4,000. For this part, we can modify the brand. For example, I can change the brand to another variable like, okay, I can change it to a variable like Huawei. However, the battery life I cannot change. Even if you look at the list of suggestions, there's no variable like battery life. So it is not available outside the class. And therefore, you can't change it or give it a new value. That's the way we can protect or use access modifiers to hide data from external access. To summarize, here's what we learned. A class is like a template or a recipe for creating objects. Objects are instances of a class, just like individual phone based on the phone template. Constructors help us to initialize objects with properties right away. Visibility modifiers control who can access the properties and mode and method of a class. If you enjoyed this video and found it helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss future tutorial. Let me know your thoughts on the question in the comments below. Happy coding!